Good day, Dr. Leo. We are Group 3, and today we will do a presentation about Joule's experiments. James Prescott Joule, a brilliant 19th century physicist, conducted groundbreaking experiments from his home lab, exploring the relationship between heat and mechanical energy. His most famous work involved measuring the mechanical equivalent of heat, a key concept in thermodynamics. Joule's contributions to science led to the establishment of the joule, J, as the SI unit of energy, and his legacy continues to influence modern physics. He passed away in 1889. In the early 1840s, Joule discovered Joule's law, showing that heat produced by an electric current is proportional to the square of the current and resistance. In 1843, he conducted the paddle wheel experiment, linking mechanical energy to thermal energy by measuring the temperature increase in water stirred by a rotating paddle. In 1852, Joule, in collaboration with Lord Kelvin, discovered the Joule-Thomson effect, explaining how the temperature of a gas changes when it expands without doing external work. In 1850, Joule's work also contributed to the formalization of the first law of thermodynamics, which states that energy in a closed system is conserved and can only change form, not be created or destroyed. In Joule's experiment, an insulated container filled with water acted as the calorimeter. A paddle wheel, connected to a vertical shaft, was powered by weights suspended outside the container. When the weights were released, they fell due to gravity, rotating the paddle wheel and stirring the water. Joule measured temperature changes in water using thermometers after mechanical work was done. Falling weights transferred energy to the water through the rotating paddle, raising its temperature. Joule's experiment proved that mechanical work can convert into heat, demonstrating transformability and energy conservation. The production of heat is explained by this fundamental principle, which is now referred to as the mechanical equivalent of heat. In Joule's experiment, the goal was to connect mechanical work with heat energy. This led to the mechanical equivalent of heat, showing how work done can produce heat. This is the equation for mechanical work done, W equal to mgh, where m is the mass of the weight, g is the gravitational acceleration, h is the height the weight falls. For heat energy, we use Q equal to mc delta T, where m is the mass of water, c is the specific heat capacity, delta T is the temperature change. The key equation is W equals JQ, where J 4.18 J per cal converts between joules and calories, linking mechanical work to heat. By combining mgh equals JQ and Q equals mc delta T, we get mgh J mc delta T. This shows how gravitational potential energy can convert into heat energy, demonstrating energy concentration. James Prescott Joule showed that mechanical work produces heat in his paddle wheel experiment with falling weights stirring water. He found that 1 calorie equals about 4.184 joules, laying the groundwork for the first law of thermodynamics, which states that energy cannot be created or destroyed, only transformed. Joule's work greatly advanced our understanding of energy conservation. Joule's law states that the heat generated in a wire is proportional to the resistance and the square of the current. This shows how electrical energy becomes heat. Additionally, the Joule-Thomson effect, discovered with Lord Kelvin, explains how gas cools during expansion without work, which is key for refrigeration and gas liquefaction. Here is a simple example of calculating the rise of temperature by using MATLAB. When 1,000 joules of potential energy is lost, it converts to an equal amount of heat energy, producing 1,000 joules of heat. This heat energy can be used to heat 1 kilograms of water. By using MATLAB for calculation, the rise in temperature of water will be 0.238 degrees Celsius. In summary, Joule's experiment revealed the relationship between heat and mechanical work, demonstrating the conservation of energy. This insight transformed scientific understanding of energy and laid the foundation for modern thermodynamics. Here are some of the references we used for this assignment. That's all from us. Thank you.